Today we're going to discuss using functions involving e. And e is a number, kind of like pi, and the italicized e is the symbol for that number. Your essential question is, what are different types of transformations of graphs of e? So first of all, the natural base e is the Euler number. And I know it looks like Euler, but it's actually pronounced Euler. And it's approximately equal to 2.718218228. And so you can kind of see after the 2.718 it goes 28128. And so it just keeps like repeating. Now we're going to simplify some natural base expressions. And these are just expressions using e. Now, if I have e squared times e to the fifth, I'm going to treat this just like e is a variable, and I'm going to leave it in that form. Now, you might remember when we did these earlier that when we multiply numbers like this, we add the exponents. So I wrote some notes over here to the side to help you guys remember what to do with the numbers in front. And this is what you do with the exponents. So right here, this is what you do with the numbers in front. And then this is what you do with the exponents. So when we're multiplying, we multiply the numbers in front. In this case, there aren't any. And we add the exponents. So this would be like e to the 2 plus 5, which would be e to the 7th. So that would be your answer. Now when we divide the numbers in front, the coefficients, and we subtract the exponents. So 12 divided by 3 would be 4, and 4 minus 3 would be 1, which would be like e to the first. So the answer would be 4e. So you're going to multiply and add, divide and subtract. The third one that we did was raising a power to a power. So that is raise the number in front to the power and multiply the exponents. So we're going to take 5 to the second power, and then we're going to multiply the exponents. So we would have e to the negative 6x. Now remember, we can't have negative exponents in our answers. So how do we change a negative exponent to a positive? Well, you move it to the opposite side of the fraction. So 5 squared is 25. That's going to stay on top. And then we're moving e to the 6x down to the bottom to make it positive. So this would be the answer. So here's your 3 things that you need to remember. Multiply and add, divide and subtract, raise and multiply. So we multiply the numbers in front, add the exponents, divide the numbers in front, subtract the exponents, raise the number in front to the power, and multiply the exponents. If you remember these, you won't forget what you're supposed to do with each problem. Now we've also done some stuff with radicals lately. So if we're taking like the square root of 25e to the 8th power, remember when you have variables and exponents underneath your radical sign, you take the exponent divided by the root. So since this is a square root, it's really like there's a 2 here. And so the square root of 25 is just 5. And then I take the exponent divided by the root. So 8 divided by 2 would be e to the 4th power. So that would be the answer. Now, how do I tell the difference between growth and decay with e? So we've been working with exponential functions in the form y equals a times b to the x power. And so since e is in the place of b in the equation, what we have to do is we have to look at the exponent of e to tell if it's growth or decay. Because remember, if b is greater than 1, then it's a growth. And if b is less than 1, then it's a decay. So since e is in the place of b right here, if I had like y equals 2 times e to the 2nd power, well, since e is equal to 2.8 approximately, or 2.718 approximately, then if I take that to the 2nd power, it's going to still be a whole number. And if I had like x here, then e squared would still be a whole number greater than 1. So it would be a growth. Okay? But if e has a negative exponent, like if it was e to the negative 2x, then that would be like 1 over e squared, which would make it less than 1. So that would be a decay. So to tell if it's going to be growth or decay, you just look at the exponent of e and tell if it's negative or positive. So if the exponent is negative, it's going to be a decay. If it's positive, it's going to be a growth, just like these examples I showed you over here. So we're going to look at these and we're going to tell if the following represents an exponential growth or decay. So if we look, this has a negative exponent. So if we rewrote that, it would be like 3, sorry, I need to erase this, 3 over e to the x power. And so then that would be less than 1. So, or it'd be like 3 times 1 over e to the x. Okay, so since this is less than 1, it's going to be a decay because the exponent's negative. Okay, for this one, e to the 5x is positive, so it's going to be a growth. So if the exponent is negative, it's decay. If it's positive, it's a growth. And that's only with these types of functions, but it could work for other ones as well. All right, we're going to graph some functions of e. So we're going to graph f of x equals e to the negative 0.75 times x minus 2 power plus 1. Then we're going to state the domain, range, and we're going to talk about the asymptote. So if you look at these first, when you're plugging these into your calculator, you need to be very careful how you plug them in. So you're going to plug it in as e to the negative 0.75 power times, and then you want to do parentheses again, negative 2 minus 2 parentheses, and so you'll have double parentheses, and then plus 1. And the plus 1 has to be outside the parentheses because it is not part of the exponent. Okay, so I want you guys to take a minute, pause the video, and you can plug these in, and then just make sure that you get the same answers that I have on my table when you get finished. Alright, so if you plugged in from negative 2 to positive 2 for x, these are the numbers that you should have come up with. If you didn't get these numbers in your calculator, let me know in class so that I can show you how to correctly plug these in so you don't get them wrong on the test. Now, if we were to graph these, I can't graph negative 2, 55.6 because it would be way up high off my graph. Negative 1, 10.5 would be just like above our little line right here. Then I have 0, 5.5. And then 1, 3.1. And 2, 2. Now, I'd kind of like to plug in some more numbers over here so that I get a more accurate picture of what my graph looks like. So I'm going to take a moment and plug in also 3 and 4 to see what happens to the rest of my graph so that I can get a better picture of what's going on. So I'm going to plug in 3 for x. So if I go back up to my equation, then I'm going to have 3 minus 2, which would be 1. You can do it that way and then multiply it by negative 0.75. So that would be like 0.75 negative, and then so we take e to the negative 0.75 power, and then plus 1. So that would be about 1.5. And if we plug in 4 for x, then 4 minus 2 is 2. And if I take 2 times negative 0.75, then I get negative 1.5. E to the negative 1.5 power, and then plus 1 would be about 1.2. Okay, so I'm going to graph these. So I have 3, 1.5, and then 4, 1.2, which is just a little bit lower than that. And if I keep plugging in numbers, what's going to happen is it's going to start flattening out closer and closer to positive 1. And I'll tell you how I know that. If I look at my equation, it has a plus 1 at the end, which means that it's going to shift up 1 from the parent function. So normally all of our graphs flatten out at 0, but if I move it up or down, then it's going to change. So right here, since it flattens out at y equals 1, that is going to be my asymptote, y equals 1, because I moved the graph up 1, so it's not going to flatten out at 0, it's going to flatten out at 1. And if you're not sure, then just keep plugging in numbers and you'll be able to kind of tell where it flattens out naturally. Okay, now let's discuss domain and range. So for domain, if I look at what I plugged in for x, I can plug in anything I want. I can plug in negative numbers, positive numbers. There's no restrictions. So the domain is all real numbers. Okay, and the range, I have to look at what y equals. So if I'm looking at the y-axis right here, my graph, all my numbers start at a 1 or above. And if you look, it never actually equals 1. It gets really close, but it never actually touches 1. So it can't be equal to 1, but it can be greater than 1. So my domain is going to be y is greater than 1. Because if you look at your y-axis, everything is above 1. Now we're going to look at these equations, and we're going to describe the transformations of each function, given the parent function is e to the x power. So just taking that regular thing, we're going to decide what happens on these graphs. So kind of if you look at these functions, there's kind of a general format. There's y equals, and then you can have a times e to the x minus h plus k. Now, you can also have a negative sign in front of these. If there's a negative sign in front, that indicates that there is a reflection of some sort. So it means it's going to flip over the x-axis. Okay? This number up here in the place of h tells you if the graph moves left or right. And because it's minus in the formula, it's opposite of what you think it is. So if it says plus, it actually moves left, and if it says minus, it actually moves right. And then this number in the place of k tells you if it goes up or down, and it's plus if it's up, down if it's minus, so that one's easy to remember. The last thing that I forgot to tell you is a. So whatever a equals tells you if it stretches or shrinks. Okay, if a is greater than 1, it's going to stretch, and if a is less than 1, it's going to shrink. So these are very similar to the square root and cube root functions that we just graphed, and also the absolute value functions that we graphed earlier on. So it's all kind of the same thing. So if we look at this one, this value in front, 0.6, is less than 1. So it means that it shrinks by a factor of 0.6. Okay, and then the minus 2 right here, remember minus means right, so this is going to go right 2. All right, let's get a different color and do the next one. For this one, we have a negative in the front, so the negative means that there is a reflection over the x-axis. The negative 4 means that I'm sorry, not the negative. The negative is a reflection. The 4 is greater than 1, so it's going to stretch by a factor of 4. The minus 2 means that it goes right 2. And the minus 5 means that it goes down 5. Okay, because this number means right or left, this number means up or down. So if you want to, take a minute and pause the video and try the next two and see what you get. Okay, I'm going to go ahead and move on. So this one, 4/3. Is 4/3 greater than 1 or less than 1? Well, it's an improper fraction, so it's greater than 1. So this one is going to stretch by a factor of 4/3. Okay. The -1 in the exponent means that it goes right 1. And the +1 means that it goes up 1 at the end. Now, this last example is kind of tricky. They're trying to trick you because it's out of order. Okay? Really, you could switch these two around. So we could put the +3 at the end over here. Okay? So really, since the 1/2 is in front, it means that it is shrunk or shrinks by a factor of 1/2. Okay, the -5 here means that it goes right 5. And the +3 at the beginning or at the end means that it goes up 3. All right, one more thing, and then we're finished. So we have continuously compounded interest. Now, we talked about compounded interest before, and that had a different equation. But when interest is compounded continuously instead of a certain number of times per year, you're going to use this formula, which is, we like to call it the PERT formula, which is P times E to the RT power. And P, again, is your principal. Okay. R is the rate, and remember we express it as a decimal. Okay. T is the time in years. But it's going to be compounded continuously. So in your problem, you'll have a problem like this. You deposit $4,000 in an account that pays 6% annual interest compounded continuously. So that's your key phrase right there. When it says compounded continuously, you have to use the PERT formula. And it says, what is the balance after 1 year? So P, we know, is 4,000. The rate is 6%, which is a decimal, would be 0.06, and the time is 1 year. So we're just going to plug these into our formula, and then E is the Euler number E, which is on your calculator. And so what we're going to do first is we're going to have our formula. We're going to plug these numbers into the formula. So we take P, which is 4,000, times E to the 0.06 times 1 power. Now, I like to kind of work this part out first, but if you want to do it in your calculator, you can. You just have to be really careful how you enter it. So I like to figure out what this is in my calculator first and then re-enter it. So if you did it correctly, you should get about $4,247.35. And remember, you want to, this is talking about money. So you want to label it with a $sign and you want to round to the nearest penny. So make sure that you go back and answer your essential question and write the summary. Thank you.